Calipers are of two kinds. They are either vernier calipers, which come with two sets of sliding rulers on them, or like this, they have a big round dial. This is a fractional caliper. Well, actually, the dial is calibrated in both fractions of an inch as well as in decimals of an inch. It does not work in metric. This is an inch-based caliper. In this video, I'll show you how they work. We will measure in the process a wood screw for determining the size of a pilot hole for it, and we will find a wrench for the nut and the leg bolt in the picture to make sure that we have the proper size of wrench for them. Let's get started. Parts of a caliper. On a caliper like this, you can find jaws. These two big surfaces are the jaws of the caliper, and at the end of it you can see this tapered part here. The end here is used to measure coarse threads. I'll show you how. With the jaws you can measure outside diameter, or you can take outside measurements. On the caliper you've got these spurs here. With it you can take inside measurements like that. And on a caliper you have a third kind of measurement that's visible on the back side of it. It's got a metal rod in it that when the caliper is slid open and closed, that metal rod comes out from the end of the caliper there to measure depth with it, like so, and then you take a reading on it. Okay, so those are the parts and functions of a caliper. One more thing about the jaws of the caliper here. There's supposed to be a little gap here where I put this needle in it. It's purposefully made there so that when you're measuring around the rough edges of it, of anything like so, then more like so, then any occasional burrs along the edges here don't interfere with the measurement, and this is more like a little hole to create a clearance around the uneven edges of an object being measured. This caliper has two thumb screws, one here and another one here. This lower thumb screw, when I loosen it, makes the bezel go around here. Now this has to be set to 0, just like that, and when you have it, just tighten this little thumb screw, because otherwise you have no way of determining any of your measurements. And this thumb screw at the top here locks the caliper's measurement in, so when you measure something like that, you can lock your measurement in, remove the object, put the caliper down, and take a reading that way, so your measurement stays set. Okay. On the main scale on the caliper, take a look at the numbers. Everything is in inches or fractions of an inch on the lower side, or along the lower edge of the caliper here, with no fine gradations. So here you have 0 inch, 1/8, a 1/4 inch. Now the 1/4 inch mark is found to the right of the number. So this one is not the 1/8 of an inch line here. This one is the 0 line. Okay, that one is the 1/8 line. That one is the 1/4 line. That one is the 3/8 line. On this caliper, this number belongs to the line to the right of the number. Okay, and on the top edge of the caliper, we have also 1 inch there, 1 inch there. So those line up, and 0 there and 0 there. But while along the bottom of the edge, the 1 inch has been divided into 8 parts. 1/8 being one part of them. Along the upper edge, the 1 inch has been divided into 10 parts, one being 1/10 of an inch. This fractional slash decimal caliper will also give you a better grasp on the concept of the difference between a decimal inch and a fraction of an inch. Okay, let's get started and let's measure something. How about this little wood screw here? With this wood screw that is to be inserted into and driven into a furniture, say a particle board splits super easily, and we don't want to split the furniture, and we want to drill a pilot hole for it. The size of the pilot hole, the size of the drill bit for the pilot hole should be exactly as thick as the minor diameter on the screw. If you're not familiar with this terminology, watch it on metric versus imperial thread. It's another video title I made. But basically, the top of the threads on both sides form the outside diameter of the or the major diameter of the thread, and from the valleys here between two threads, from valley to valley across here, forms the minor, sorry guys, the minor diameter on the fastener. So we're going to measure the minor diameter on this one, and this is how it's done. Just bear with me and wait for the focus here. Oh, almost. There we go. You can see how the fastener is being measured here between the jaws on the caliper. Let's see if I can change the light and make it any better. Not a whole lot. Just bear with me. It's a tricky shot there. There you can see how it's how the jaws of the caliper are right against the shank of the screw there, and let me just go just a little closer. Sorry guys. Thereabouts. You can see how the caliper is grabbing the screw, measuring its minor diameter, which is the outside, which becomes the outside diameter on a twist drill bit. Okay, so let me take this caliper, this screw out here, and put the caliper down so we can take a look at the measurement. Obviously, the minor diameter of the screw is less than 1 inch. One important step, and the first step, is to determine the whole number of inches, and that determination comes from comparing this edge of the caliper here, which is part of the sliding dial assembly on the caliper. Okay, this edge on the dial assembly against the main scale on the caliper. You have to read these fractional numbers first. Okay. Now, the for whole inches, there is your first number. It's 0 inch. Okay. Yeah, it's obvious on this one, but when you're measuring things bigger than an inch, it's not going to be so obvious, and you need to put that number down. Okay. So 0 inches. I'm gonna write it up on the board. So far we have 0 inches. And then we have a fraction. The fractional part in eighths of an inch also comes from this part of the caliper here. Maybe just reframe it a little bit like so. There, you can see it better. And you have to determine how many eighths of an inch is this edge of the caliper passed on the main scale. Now, the line for the 1/8 of an inch hasn't been exposed, so the measurement for the minor diameter of a screw is less than 1/8. Okay? the third step of taking a measurement with calipers is taking a look at the dial. Let me just try to change the light to see if I can get rid of the glare. I'm gonna use this pencil a little bit here. Yep, that's a little better. Okay. It's a tricky shot, just bear with me. Let me just get rid of those letters and let's see what we've got on the dial. How do we read the dial? Let's zoom in, and on the dial you can see two sets of numbers. One set of numbers is along the outside of the dial, and they are against a blue background. Another set of numbers is further to the inside, and they are against a white background. Okay, just in case you're challenged with colors, the outside numbers have a blue background and the numbers to the inside have a white background. Likewise, you've got two numbers here in the middle of the caliper dial. This one says 1/64 of an inch and it's in white. So the numbers with against a white background will represent every hairline, every distance here, like that, represents 1/64 of an inch, every little distance there. And likewise on the outside of the dial face here, this one says 0.01, in other words 1/100th of an inch. Let me just grab another color. So every little division here represents 1/100th of an inch. Even though I said the outside is decimal, I wrote a fraction. That's 1/100th of an inch, just as that format is 1/100th of an inch. Okay, the format of the number doesn't change the fact that it's still a decimal, a 10-based fraction, okay, or a 100-based fraction. So back to the reading for the minor diameter of the screw. You can see on the needle that it indeed hasn't reached the 1/8 mark yet. So in this sense, this is just double checking the initial measurement that was taken, that it's less than 1/8 of an inch, because sometimes the edge of the sliding caliper assembly might overlap or may not expose fully, or given the lighting in a shed, for example, you may not be able to see whether indeed you cleared the 1/8 mark or you haven't. There, you can double check it with the dial on the dial face. So the 1/8 of an inch is here, and you haven't passed it yet. Now, because the white divisions here indicate 1/64 of an inch, we can also double check it. How many parts has the 1/8 been divided? 1, 2, 3, 4, 5, 6, 7, actually 1, 2, 3, 4, 5, 6, 7, 8 parts. The 1/8 has been divided into 8 parts, and indeed that is 64th, because 8/64 is the same as 4/32, or 2/16, or 1, and it's ugly, or 1/8. So you can see that equivalent fractions here, that 1/8 of an inch is indeed 8/64. So how many 64th? We'll just count it now. 1, 2, 3, 4, 5, 6, 7. This needle here is pointing at the 7/64th. So the minor diameter on the screw is 0 inches and 7/64 of an inch. That's your measurement in fraction format. Now decimals of an inch. You count the lines the same way along the outside of the circumference of this dial here, and every division is 1/100th of an inch. So 100ths, 200ths, 3, 4, 5, 6, 7, 8, 9, 10 hundredths. That's 1/10 of an inch, yeah? Like so. That's 10 hundredths, 11 hundredths. And 11 hundredths is written like so. 11 hundredths of an inch. There. 2 whiskers. So 11 hundredths of an inch for the minor diameter of the screw. Now let's measure something else. Something that's bigger than an inch. Let me just zoom out. And I'll just get rid of those numbers. And say, let's measure the size of, here's a leg bolt. Okay, we want to determine what size of a wrench should be used on this leg bolt, because the thread on it is different from that of a machine screw thread. This thread is a wood thread. Okay, it's not gonna get a nut on the opposite side of it. It's gonna be biting into wood, so you need to make sure that you have the proper size of wrench on it. How do we make sure? We measure. Let me just focus with the camera. There about so you can see it. There, put the jaws on it, make sure they are nice and tight. And take the item out. And let's measure. Okay. So, first thing to do is, again, same procedure, determine the whole number of inches first. Let's start at the 0. There's 1/8, 3/8, half an inch, 7/8. The 1/8 is coming there, but we really haven't passed the 1 inch mark yet. So the size of wrench that's needed for this leg bolt is going to be less than an inch, just a shy. Just a hair shy from an inch. That's important that the information is recorded, and I'm going to write it there. So 0 inches, it's not even 1 inch yet. Next up is looking at the dial here. On a dial, there. On a dial you can see the number of 8s as well, as you can see it on the main scale. So you can see that the dial turning clockwise has passed the 1/8, the 3/8, the half inch, 3/4 and the 7/8 mark, as you could see it on the main scale. So we're going to be a little more than 7/8. I'm going to write 7/8 here, and we're going to have to do a fraction addition there. And just reposition this one a little bit, like so, so that my red numbers are against the white background. Okay, 7/8, and then we're counting the 64ths. 1, 2, 3, 4 64ths. 4 64ths. Now, what's the fraction? 4 64ths has an even number up top, so it has a smaller fraction that you can reduce it to a lower term. 4 64ths is 2/32 or 1/16 of an inch. 1/16 is at its lowest terms. Now we need to add 7/8 and 1/16. 7/8 is 14/16 of an inch, and now we need to add 14/16 and 1/16, and when we add them the result is 15/16. So to have the proper size wrench for the leg bolt, we need to get out the 15/16 wrench. It's 0 inches. I'm going to write it this way: 0 inches, and it's the 15/16 wrench. Now in decimal inches, I'm just going to get rid of this one. In decimal inches, we do the same thing. It's less than 1 inch, so we know that it's going to start with a 0.0. That's 1/10, 2/10, 3/10, 6/10, 9/10. So we write down 9 for the 10th place value, and now we start counting the hundredths. 100th, 200th, 300th, and we write down that one. And if you write down the 300th, that's going to be a little undersized. You can see that the very tip of the needle here is between the 3rd hundredth and the 4th hundredth. How about that? 935,000th of an inch, and that's a close decimal approximation to the fraction 15/16. If you wanted a super accurate decimal conversion, just grab a calculator like so, and go 15 divided by 16, and that number. I say my measurement is pretty close to pretty close to the decimal conversion done on a calculator. So that's how you take measurements in decimal inches on a fractional or a decimal caliper. Last measurement to do is we're going to measure the size of this nut really fast here. Same procedure, fewer words, so you can see the action part. Take a measurement there, tighten the thumb screw, take out the nut, and take a look at the stationary scale there on the main scale, and record the numbers. We are past the 1 inch there. The 1 inch mark has clearly been passed. So I'm going to record, and where do I write it? 1 inch, and there's going to be 1 inch, and there's going to be more to it. We're past the 1/8, the quarter, the 3/8, and not exactly past the ½ inch, but it's going to be 3/8 plus a little more. Let's take a look at the dial, and let me zoom in. I'm just going to put this pencil underneath there to change the glare a little bit. There, let's count the 64th. So there's 3/8, 1/64th, 2, 3, 4, 5, 6/64th, and a little bit. How about 7/64th? Let's be generous on this one. 7/64th, because you won't be able to put a wrench smaller than the measurement on it, so you gotta round it up a little bit. Now we need to make these two fractions and add them, and for that you need common denominators. So 3/8 is the same as 6/16, sorry, 6/16 or 12 30-seconds or 24/64. Okay, 3/8 is the same as, I'm doubling the numerators and the denominators. 3, 6, 12, 24, and 8, 16, 32, 64. So we've got an equivalent fraction of 24/64 plus 7/64, and the sum of these two fractions is 31/64. 31/64 of an inch. Okay, so that's a pretty good measurement on that one. However, there's a problem. I haven't seen a manufacturer who manufactures an inch that has a size of 31/64. Most manufacturers just go for a ½ inch. Okay, and they undersize the fasteners, the bolt heads and the nuts intentionally a little bit, because like here with about 1/64 of an inch, because the fastener head could be, and this is called tolerance in terms of manufacturing, it could have a burr on it, or it could be just a little bit out of shape, or somebody drops it and it deforms slightly, so you still need to be able to put a wrench on it. So basically, just go for 1.5 inch socket or 1.5 inch wrench, even though the measured size is 31/64 of an inch. Just go for 34/64 half inch. Lastly, in decimals, we have the same one for whole numbers. So the 1 is standing in the ones digit place, and let's look at the tenths. 1, 2, 3, 4 tenths, but not quite the fifth. So 4 tenths is recorded, and we're counting the hundredths from here on. 1, 2, 3, 4, 500, 6, 7, 800. There, 1.48. So 1 inch and 48 hundredths. That's the size of the nut that I just pulled out of the drawer. That's how to use a caliper with a dial face that's graduated either in decimals of an inch or fractions of an inch.